Here's another place where we can use the formulas for the sums and differences of our trigonometric functions. Note here, we want to find the exact value of sine inverse root 3 over 2 plus cosine inverse 1. Now, remember our mantra, we said that the output of the inverse function is an angle. So when we look at this, we should still be thinking of it in terms of sine of alpha plus beta, because sine inverse gives us an angle and cosine inverse also gives us an angle. So the first thing I'm going to do is write out my formula for the sum of the cosine function, sum of two angles for the sine function rather. And so we get sine alpha cosine beta plus cosine alpha sine beta. Or in terms of what we have here, we have sine of sine inverse root 3 over 2. Okay, remember this is my alpha. And then I've got cosine of cosine inverse 1. Okay, that was my beta. So far I've got sine alpha times cosine beta plus cosine of sine inverse of root 3 over 2 times sine of cosine inverse 1. Okay. All right, so we've got it written out according to the formula. Now we need to go back and try to figure out what all of our different pieces are for this. Okay, so sine of sine inverse root 3 over 2, we talked about this a good bit in sections 3.1 and 3.2. We need to think about where the inverse sine function is defined, and I'll just make a little diagram over here. Remember, sine inverse, we get outputs between minus pi over 2 and pi over 2. Okay, if we're talking about sine inverse of root 3 over 2, we know we're going to be here in the first quadrant because that's where we would get the positive values for the sine function. And so just kind of thinking backwards, if you want to do it that way, you can think about the angle, or if you don't know which angle it is, and it is the pi over 3 angle, then you can draw the picture. Okay, we could still draw the picture if we needed to. I know I need to be in the first quadrant, okay, because we're talking sine inverse and I've got the positive value there. If I don't know what the angle alpha is, I do know that sine of that angle has to be root 3, my opposite, over 2, my hypotenuse. And of course, that gives me 1 there. However, we also know that sine and sine inverse cancel out. So we can just say sine of sine inverse of root 3 over 2 is root 3 over 2. Okay, cosine of cosine inverse of 1 is just 1. Okay, but what about cosine of sine inverse of root 3 over 2? Well, that brings us back to our triangle. Again, if you know the angle, which we said it was pi over 6, or not pi over 6, it would be pi over 3 or 60 degrees, then we know that cosine of 60 degrees is 1/2. However, we also see that by looking at our triangle here. Here's our adjacent, here's our hypotenuse, and so we get 1/2. Okay, sine of cosine inverse. Again, we think about where that happens. Cosine inverse of 1, the cosine function, or cosine inverse function rather, um, has a range from 0 to 1. Okay, we get a value of, I'm sorry, a range from -1 to 1. Okay, over here cosine is -1, and over here it's 1. Okay, we're looking at 0 to pi. Okay, that's the range from 0 to pi. And so where do we get a value of 1? It's right here at 0. Okay, so we get sine of 0, and of course we know sine of 0 is just 0. And so our final answer is just √3/2. Okay, let's try that again in this next example. So we've got cosine of tangent inverse of 4/3 plus cosine inverse 12/13. Again, the output of the inverse function is an angle, so I'm going to think of these things as alpha and beta. Okay, and so I'm going to start by writing out my cosine formula. The formula for cosine is cosine alpha cosine beta minus sine alpha, or yeah, this one's minus sine alpha sine beta. Or in terms of what we have, this is cosine of tangent inverse 4/3 and then cosine of cosine inverse 12/13. Okay, minus sine of tangent inverse of 4/3 and sine of cosine inverse 12/13. Okay, so now we're going to go and start looking for anything where we might be able to cancel out, and we only have a little bit that's going to cancel. That's going to be right here, cosine cosine inverse of 12/13. That's 12/13. We can cancel out as long as this value is in the range of the cosine function. And of course, we know the range of cosine is from -1 to 1. So 12/13 would be within that range. So those cancel out. For everything else, we're going to need to draw a triangle. So let's go ahead and start with cosine inverse first. We'll start with this piece. Maybe it'll be a little easier since we work with cosine a little bit more. But when I think about where this angle is located, it has to be in quadrant 1. Okay, remember cosine inverse is defined from 0 to pi. So okay, this is where cosine inverse function, we get our values out. If we're talking about 12/13, we're in this first quadrant. I'm going to draw triangle. Okay, remember cosine inverse of 12/13 is some angle of which we can say cosine of that angle is adjacent, or 12 over hypotenuse 13. Okay, and we know this is a Pythagorean triple, so we're going to put the 5 there. Now when I take sine of this, we get opposite over hypotenuse, or 5/13. Okay, now we're going to draw another triangle for the tangent inverse function. And we know that tangent inverse, it follows sine inverse, which is defined from minus pi over 2 to pi over 2. Okay, or that's the range. So we're looking at since the value is positive here, again, we're going to be in the fourth quadrant. Okay, here's my angle. And so we are going to do opposite over adjacent. My opposite is 4. My adjacent is 3. This is another Pythagorean triple. I get 3, 4, 5. Okay, now I can say cosine of whatever this angle is going to be adjacent over hypotenuse, 3/5. And then sine is going to be opposite over hypotenuse, 4/5. And so we get 36 over 65 minus 20 over 65, or 16 over 65. All right,